Hello and welcome back to AI Daily. We have another three great stories for you guys today. I'm your host, Connor, joined once again by Ethan and Farr. Starting up first, we have Meta's Chameleon, the more efficient, state of the art generative model for text and images. So, this is transformer based instead of diffusion based, as we've seen for most models for a while. So, instead of being just text to image or just image to text, like we see most models, this is multimodal and they can go with do both and work both ways. And because of that, it's apparently 5 times smaller and a lot more efficient than a lot of these existing models. And again, because of how it's architected, it can do some very fancy things like instruct fine tune on text and images. So you can give it a picture of a dog holding a stick and be like, what is the dog holding in its mouth? And the model will be like, a stick. Looks like it's very well architected and looks like it works very well. Ethan, I heard you had some opinions on it. I'd love to hear them.
It is absolutely amazing. If you look at the examples, they look fantastic. It's a multimodal model. So you get, just like you said, you get the text in, you get the text out. So you got this kind of clip-esque interface. You can actually ask questions about images. You can generate these actually extremely high quality images. They have structure guided editing. So you can actually edit these images in a way that, some tools have tried to put together manually, but this is built in at the model level. Like you said, it's transformer based. And I'm honestly just blown away with the results they've been getting. I think this is above mid journey level just from the few examples I've been seeing so far.
Yeah, it's for a while we've had diffusion and transformer models were kind of hard to make and hard to make well and hard to architect well, but this is made very simply and it looks to work very well. Far, what do you think of it? What do you think of the multimodal parts of it? What do you think?
It's super impressive. You can do a lot of pretty nuanced and specific things. It handles segmentation. You can, tell it to create an image where there's a bottle in this location of the image, there's a bed in this location of the image. It can do that. So it understands the objects in the image. You can give it an input. It can do segmentation, generate new things off of the segmentation. The resolution is really high. It's beyond impressive and, not surprising given the engineering talent and resources they have at Meta. Makes you wonder what else they have under the hood. But probably the most impressive thing is that it can make hands. That was the
And
that was
text.
that was the
And
mind blowing moment. Yeah, text. Yeah.
yeah, they ask it to make hands in a certain position and does it exactly with the right amount of 5 fingers, or it asks it to put words or text on a sign, and that works also. So very flawless, a knock out of the park by Meta once again. Next up, we have HyperDreamBooth. This is hyper networks for fast personalization of text image models. Of course, we've seen Dreambooth for a while. Now we saw Style Drop recently. And this is apparently takes only 20 seconds to run, which is about 25 times faster than Dreambooth's. And it's far more efficient. And it's a model that is about 10,000 times smaller than what you can get out of Dreambooth. These are pretty huge advancements, especially considering it can take in only one image versus the 10 or 20 Dreambooth normally takes. What do we think of these benefits?
I mean, to give a little bit of perspective to the 10,000 times smaller, it's they get the model down to 120 kilobytes. You could you could put this on a floppy disk from 1985 to give you a little bit of context. It's pretty bonkers. They can process stuff in a couple of seconds, like you said. But I was pretty, 120 kilobytes of storage for a 30,000 variable model. So just mind bending.
Yeah, you can plug your floppy disks into your A100 GPUs and get your Stable Diffusion outputs.
Most of them come with floppy drives these days.
Yes, most of them do these days. Ethan, what do we think of it? The images look pretty good in my opinion, even better than normal Dreambooths. What do you think?
Yeah, I haven't got to use it yet, but as you both know very well, when we deployed Namesake last year, we were dealing with petabytes of fine-tuned files. We were dealing with 10-minute training times. We had over 500 A100s going. So, we've progressed from that age of Dreambooth, which was only 8 months ago. And then we saw January, February, kind of March-ish, you started to get these LoRa's, right? And LoRa's were a different type of, not truly fine-tuning, but of the sorts. You can generate a couple megabyte files. The quality was definitely not as there. It was few shot. So now you have HyperDreamBooth. With one image, you can actually gen these things in 20 seconds, like y'all said, and a way smaller file size. To me, the architecture is really cool, but just speaks to the pace of this development. From where we were in November to where we are now, this is a completely different ballgame. This is something that you can embed in an iPhone app and let it run. This is something you can embed on a Raspberry Pi in the middle of nowhere. This is not something you need huge GPU clusters to manage anymore. So the pace of this space is astounding.
Yeah, to be fair, that's the powerful thing here. The images are very good, but I don't think they're state of the art. But for 10,000 times smaller, storage size, that's a different state of the art. So really impressive.
Yeah, between GGML and some other architecture improvements, you could definitely adapt this to run on an iPhone with the latest processor of an iPhone. You can store the model on an iPhone directly. You could get everything you get out of DreamBooth, everything we did with Namesake, could probably run directly on an iPhone app nowadays, which is insane, really.
Yep.
Well, lastly today, we have Animate-A-Story, which is storytelling with retrieval-augmented video generation. So, of course, the hardest part about making these text videos is the actual motion in the movement of the video itself. And so they combine a motion structure retrieval where they basically kind of vector search or just search a database of videos for the motion of the video itself. And then they adapt that with structure guided text to video synthesis, where they basically just adapt each frame and do some other fancy mathematics and computer science and adapt a frame of someone doing yoga to a frame of a teddy bear doing yoga. And the videos look a lot better. This is what I've seen. This is probably the best I've seen from any text to video model. Ethan, you've looked at a lot of text to video. What do you think of this?
I think right now we're at the, interesting engineering hacks age of this. And this one is a very strong one. If you've ever looked at text to video or messed with it, spatial and temporal is extremely hard. Temporal is one thing, but spatial is just extremely hard. How do you get consistency across frames, right? And they pretty much added a really interesting thing, which was, hey, we can stylize videos, right? We've seen a lot of different with Runway or any other models saying, hey, I'm going to take a video of myself. I'll use a control net or I'll stylize myself into Spider-Man or a bunny, right? But when you're going text to video, it's like, okay, we're starting with no video. Why don't we just search a database of videos that might be similar and then stylize them? So really cool kind of engineering hack-esque. The videos were actually like not too bad. So this could be a potential pathway to actually high quality text to video. I'm not extremely confident on it, but I think might be part of a pipeline.
I think the second part of the pipeline, the whole like final video synthesis, that stuff's getting a lot better. But the initial motion generation, I think you're right. It is kind of an engineering hack. Far, what do you think? How are we going to see videos? How are we going to see motion in videos in the future?
Reading the abstract of this paper is not really going to let you, not going to sell it. I think like it really is. You got to read the paper to understand that they've kind of pipelined a lot of things together here. What they're talking about is going from a script to a video, which is take a script, break the script down. They don't talk too much about that because that's not the video part, but break the script down into different plot pieces, take those, generate prompts from the script, find videos that match those prompts, and then do the, create the new output based off of that video. They've strung together a lot of things here. It's a massive massive team they got here. It looks like there's like 10 people here, folks at Tencent, 10 from Tencent. And, it's pretty ambitious. It would be impossible to expect them to knock this out of the park. You'd literally be talking about replacing Hollywood with one paper if that was, really the case here. So it's a pretty cool pipeline, impressive to see, nice to see them being audacious about it too and going for it. Like, we're going to go from script to video. That's not a small challenge.
Absolutely.
It's not, no. Well, that was a very good paper and I think well done by the team at Tencent. So those are the 3 stories today. What have you guys seen? What have you guys been reading?
I have downloaded iOS 17 public beta. Amazingly enough, I actually think my phone is faster on it than it was on iOS 16, which is super impressive. And I'm trying to train my voice on it. You have to read 150. The training process for your voice is actually pretty cool. You read they made it like a little product, a little app where it keeps presenting sentences. You read the sentences and it moves on to the next one. You don't have to hit any buttons. You just sit there and read the sentence. It knows when you said it. It moves on to the next sentence. I think I'm about 30 sentences into the 150 sentences I have to read. So hopefully I'll be able to demo that. I don't know if I'll need somebody. They may not even have the part where you can actually use it done yet. I wouldn't be surprised if they did, because otherwise, why would they do the training piece? Don't know if I'll need somebody else on iOS 17, in which case I'll have to steal one of your guys' phones and force upgrade it to the public beta against your will. But we'll cover that then.
It's nice to see that the training time, the amount of data that you need has gone down. I remember during COVID, I needed like 17 hours to train the text to voice of my model. So
I think it's 15 minutes here or something like that, they say, but it doesn't really make sense. Yeah. Yeah, maybe it's about 15 minutes. 150 sentences you have to read.
yeah, that's a pretty nice jump.
Yeah.
Yeah.
I remember when you plopped down in the room and you sat there for 8 hours reading thousands of sentences for us to make that WaveNet.
Yep. Exciting times.
8 hours is a big difference.
Ethan, what about
I
you?
saw a really cool kind of a blog post from the CEO of Anthropic around what does a new Turing test look like, right? So we've kind of been basing everything on the Turing test so far. Turing test says, hey, an AI is intelligent if it can convince a human that it is not an AI and it can speak language, right? So there's a few different adaptations, but in general, that. And we've pretty much, for all intents and purposes, crossed a lot of that. I think people are realizing, and we're moving the bar on where AI is. So they've kind of came up with a new term that I really like: artificially capably intelligent. So it's, what does AI do in the world? Not just what it feels like or seems like, but what can it do in the world? So this new Turing test says, hey, we're going to lay it out and say, when an AI can make $1 million online from a $100,000 investment, well, now we're at ACI, artificially capable intelligence. So I think it's really cool. Has so many different pathways to it. This Cicero paper from Meta always interests me, as y'all both know. How can you plan and strategize and negotiate while using LLMs and actually make these artificially intelligent systems? So really cool post. I like seeing the bar of the Turing test continue to move.
Yeah, if an AI can make $1 million selling paper clips, I think that'd be a very good benchmark.
I completely agree.
No, no.
I'd be
I
impressed
saw,
if a person could do it.
or that. No. I saw
Or hire.
example-based motion synthesis by generative motion matching, a little bit similar to the teddy bear paper with the Make-A-Story. Kind of a funny video I saw. You can ask it to dance, and it can basically move a 3D model in a dance move by searching for similar dance moves. I didn't completely dig into the paper or anything, but pretty funny video, pretty funny example on Hugging Face. We'll link that below.
Very cool.
Well, thank you guys once again for another great week, another great episode. See you guys next week.
See you guys.
Peace, guys.